So in this week's video, we're going to be covering the 17th LeetCode problem, letter combinations of a phone number. Now this is a medium level LeetCode problem, and it tends to get asked when you are interviewing for companies like Facebook or Airbnb. As per the usual format of my LeetCoding problems, we're going to start off by reading the problem statement. Let's dive right in. Given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. A mapping of digits, like the one on the telephone buttons, is given below. Note that 1 does not map to any letters. Now this is like a blast from the past. I don't know if many of you guys even know what this is. I'm unfortunately old enough to use a phone which had numbers with A, B, C, D, E, F, like this, so on and so forth. Basically, we're going to figure out the different combinations that can come about with a set of numbers. So let's take this example. So here we're given 23 as the input. Since 2 can have A, B, or C, and 3 can be D, E, or F, we have to understand the different combinations that can occur. In this case, the different combinations could be A, D, A, E, A, F, or B, D, B, E, B, F, or C, D, C, E, C, F. Cool. Now that we understand the problem statement, let's dive into an algorithm that can help us solve this problem. So the easiest way to understand the algorithm is going to be looking at the examples that we've been given. Let's start off with the digits 2, 3. So when we're given 2, 3, we know that 2 maps to ABC and 3 maps to DEF. So when we are going to get the solution, we're going to need to get AD, AE, AF, BD, BE, BF, and CD, CE, CF. Now let's take a closer look with one extra digit. Suppose we have the digits 2, 3, and 3. We're going to need to get
A, B, D, A, D, E, A, D, F, and then we're going to get A, E, D, A, E, E, A, E, F. Afterwards, we're going to go to the second value inside of 2, which is B, so we're going to get B, D, D, B, D, E, and B, D, F. Then we're going to go to the second value in 3, which is going to be B, E, D, B, E, E, and B, E, F. Now the third value inside of the second digit, so B, F, D, B, F, E, and B, F, F. And of course, we have to iterate to the last value inside of the original digit 2. So we're going to get C, D, D, C, D, E, and C, D, F. Then the digit here, which is going to be C, E, D, C, E, E, and C, E, F. And finally, C, F, D, C, F, E, and C, F, F.
Now that we understand how this works, I think it's quite clear to realize that this is going to be a recursive function. So let's just go back to the 2, 3 example and see how we can solve this problem. We can have a function that takes in the digits and the current string. We're going to start off with 2, and we're going to know that we need to call it 3 times. So that's going to be the number of characters inside of 2. And we're going to say A, then we have 3B, and we have 3C. And now for each digit in here, we're going to have to call it that many times. So it's going to be 3 times once more. So we're going to have empty string A, D, empty string A, E, and empty string A, F. And again, those 3 values are going to be present in these 2 calls as well. So as you can see, we're going to be having a recursive function that iterates through the digits. So if we have 2, 3, 3, we're going to get all the characters inside the first digit, and we're going to call the recursive function each time for all 3 digits, A, B, and C. And then when we're in each recursive call, we're going to have to call it that many more times. And of course, finally, when we reach the end, we know that there is an empty string, and then we can just add that value to an array. And once we add that value to an array, we can just return that array at the end. So if this is a little bit unclear, then there is an example that I go through in the coding section so you can understand what's actually going on. So in terms of big O, we know that for the time complexity, we're going to be dependent on the number of digits that is given to us. So if there are 2 digits, which is 2 and 3, we're going to need to get all values. So there's 3 values for 2 and 3 values for 3. So this is going to be, 9. 9 different possible answers. Now if there's 3 values, let's say 2, 3, and 3, we're going to get 3 times 3 times 3, which is 27. So the time complexity can be reduced to the number of digits. Let's just say the number of digits is n, and we know that at most we can have one character which has 4 different letters. So one number, so I don't remember which one it is. It might have been like P, or sorry, it might have been like 7. It might have been 7 or 8 or 6, but one of these has 4 different letters representing it. So in the worst case, we can have a time complexity of n to the 4th. Oh, let me just clear that up a bit. And of course, the space complexity is going to follow straight from that, because we need to have a solution that encapsulates all of those n to the 4th values. Now that we've gone over the algorithm and the big O time complexity, all that's left for us to do is understand the code. So let's take a look. Now we want to start off in letter combinations, of course, with the base case. And that base case is if there are no digits. If there are no digits, there's nothing for us to do. So all we need to do is return an empty array. Otherwise, we create a solution array that's empty and pass it by reference into this letter combinations helper. Now this helper function is going to handle all cases for us, including appending all the values required for the solution into the solutions array. And since this is passed by reference, we can just return the solutions array, and that will be that. So let's dive deeper and look into this helper function. Looking at the letter combinations helper function, we notice that we pass in the digits, the current string, and the solution array. The digits is just going to keep getting decremented while we keep going in through the recursive calls. So our base case is going to be if the digits, or the length of the digits, is equal to 0. If we hit that base case, we know that the current string is the value that we need to add onto the solutions array. So all we're going to do is append it onto the solutions array and return. We're going to return back to the previous call of this helper function. If digits is not empty, then we are not at our base case. So there's at least one digit, maybe more, that we have to traverse through. So the first thing we're going to need to do is get all the letters that a digit can represent. So we're going to take the first digit, so that's going to be at digits index 0, and we're going to get all the possible characters that represent that digit. Here I just have a quick sub function that will help us get all the characters, mapping 2 to ABC, 3 to DEF, etc., etc. Once we have found the possible characters that the digit represents, we have to iterate in a for loop through all possible characters. And then we want to add that current character to our string. Once we have added that current character to the string, we have to call this recursive function again, now with the digits of the rest of the number. So we're going to exclude the first value in the digits string, and we're going to include every other number and pass in the current string and the solution. And so that will iterate through until it hits the first base case, which is when digits is equal to 0. So let's just do this quick example with 2 and 3. So digits is equal to 2 and 3, current string is equal to empty, and solution array is nothing. We know that it's not empty, the digits is 2 and 3. So we're going to start off with 2, and we're going to go into get all the possible characters, which is ABC, and we're going to add the current value, which is A, into the combinations helper. So now digit is going to equal 3, the current string is going to equal A, and S is still going to be empty. We're going to not hit this base case and get all possible characters for 3. Now we're going to add the first possible character onto the current string, and we're going to have that the digit is equal to empty string in this iteration of the recursive function. C is equal to A with AD, and S is equal to an empty array. Now, since the length of digits is 0, we know that we can just append the current string onto this solutions array. And once we do that, we return. And when we return, we decrement current string by 1 value. So now, when we go into the next iteration of this loop, current string is going to add the second value of 3, which is E. So now D is going to equal empty string once again. C is going to equal A, and E, S is going to have A, D in it. And now D is empty, so we're going to add A and E. If we go through the entire iteration, we will be given the final solution. So let's submit this problem and see if it works. And of course, as always, it does. And my fastest runtime was 12 milliseconds, which was faster than 93% of all Python solutions, so that's pretty cool. And yeah, I hope you guys enjoyed. If you guys did, leave a like and subscribe for more in the future.